Our next speaker is Hassan Ahmed. Hassan is the CEO of Affirmed Networks. Affirmed Networks is changing, how mobile operators are running their networks by replacing hardware with software components. Affirmed was recently named, I think, what was it, the next billion-dollar company to watch. So we all have high expectations here to see what the future holds.
Yeah. Thank you. Yeah, those are the 2 seconds of fame that you always get, right? Thanks, everyone. What I'd love to do is share with you a little bit of the experiences of some of the deployments we're doing. I thought that would be the most valuable for today. And what I thought I'd do is talk a little bit about some of the motivations that go into why people are deploying this, a little bit about the technology that's driving it, and then go to some specific deployments that we've been involved in. I think a good place to start is to recognize one thing about mobile networks and the problem that exists in mobile networks. I think the move to NFV, despite the large set of investments that operators have made in the mobile space, is very much driven by business. It's not really just because it's the next cool technology. It's really driven by a couple of key business imperatives. We've all heard about the growth of mobile data and so forth. When mobile networks emerged, they emerged as really just access networks. And what's happening is data is really changing. And there are really two main drivers that we see. First of all, in theory, you could just scale the network by making bigger and bigger versions of what you already have in place. But the reality is that that's a non-starter in today's environment because data is growing a lot faster than Moore's Law. So you really have to start by readdressing the network architecture as opposed to just making bigger legacy platforms. I think once you solve that problem, and certainly NFV drives a major shift in economics, once you solve that problem, the reality is the operator still has to invest in supporting this growth of data. And unfortunately, a lot of the revenue in a mobile-first world, it goes over the top. So the operator really has to start to participate in the internet economy. And in that regard, mobile networks, which have historically been access networks, need to become intelligent. And so bringing intelligence into the network to drive sort of the growth is a big piece of the puzzle. So the question is, why do existing networks not live up to that, or why do they not provide the capability? Well, here's an example of what a mobile network might look like today, both for cellular and wireless access. And what you can see is one of the real reasons that networks can't scale terribly economically is because they end up developing all these inline platforms with inline ports. And second of all, these are actually quite difficult to manage. If you want to put up a new service and an infrastructure that's broken up like this, you're looking at a good 9 to 12-month experience to do anything, which is really not internet time by any means. So the deployments that we've been involved in effectively apply a different methodology. Like I said, we address it at a network architecture level, where we effectively collapse the path from the radio out to the internet into a set of virtualized system functions. Now, I think there are good ways and bad ways to do this. So I'd say there are 3 or 4 really important elements of what we do. The first is we can collapse these functions, but just remember, performance is a major factor in going off and doing that. Obviously, if you collapse multiple functions into a into a set of capabilities running on a single platform, you have to be able to deliver the performance that the network demands. Second, I think it's a really bad outcome if all you do is virtualize individual platforms, and then you've got a software version of the same inflexible network that you started with. And that really doesn't address the business imperative for driving revenue in the network. So therefore, providing this capability in an integrated way where you can orchestrate services is particularly important, and it actually drives in a lot of ways service automation. Andre talked, for example, this morning about how quickly the automation platform is changing AT&T's ability to react to customers. This is a big piece of the business imperative that drives us to think about architecture like this. And then finally, as you see these varying workloads on mobile networks today, ranging from IoT to video and so forth, as opposed to the old days, the one thing that you have to have is the ability of these VNFs to be very disaggregated and allow signaling and data and analysis and all that stuff to scale fairly independently. And so I think there are attributes that you have to think about in virtualizing. And I'd say that really does mandate a fresh start in the technology. One of the things that we see is approaches where legacy hardware boxes get you lift the software and you encapsulate it in a VM and you call that NFV. Unfortunately, those types of approaches don't really lead to any of the objectives I think that operators are trying to deliver on if they move to NFV. I think you really do need a fresh start where the parallel software architecture target is really matched in some ways to the underlying hardware model. And I think if I think about the technology advances that have really driven performance in this space, probably the single biggest is the software architecture itself. I think if you having a parallel software model that enables a lot of the processing that you need to do in the fast path, which is quite different from historical architectures where, packet forwarding happens in the fast path, just about everything else happens in something that we call the slow path. This becomes particularly important. Now, in today's world, what's happened is that call models in the mobile world have become very, very complex. They involve a lot of DPI rules and so forth. So doing DPI processing in the fast path becomes critical to being able to deliver the performance that you want. Now, I'll give you an example of a real-world scenario. This is working at a tier 1 who was deploying, I would say, the best of the legacy platforms today and running into major performance issues. We actually were able to run our application with exactly the same call models and DPI rules and get about a 4x performance advantage on a platform that was significantly cheaper. So it gave about a 10 to 20x price performance advantage. And I think that's a really important metric in terms of where we are and the new technology really outperforming in some ways the old now. Some of the capability, I think one of the things that's happening in this space is you really have to move quickly with the technology itself. So you need to really evolve as the technology itself evolves. As switching fabrics emerged, we took advantage of DPDK and SRIOV and so forth to squeeze a lot of performance out of that. Now we're moving to open V switches. And I just think the technology is going to continue to evolve quite rapidly in this space, and being able to squeeze as much as you can out of it is particularly important. One of as you saw in what I started with, we talked about collapsing the entire data path of the mobile network. Well, there are entire companies doing pieces of that. So you ask the question, well, how are you going to pull that off? And one of the things that really turned out to be very, very valuable for us was open source, which dramatically accelerated our embedded system development. Roughly speaking, in our case, we found about a 3x acceleration associated with being able to use open source. About a third of our application code today is based on open source. That's not counting the fact that we run on Linux. One of the things that we found in building this system is that open source components provide you tremendous breadth in what's out there, everything from tools and build environments to data structures and resource management and virtualization tools like OpenStack. So it's a arena that we've embraced pretty heavily. And when you combine that with open APIs and contributing to these open APIs that are related to, say, SFC or some of the other APIs that development, it really makes a huge difference in how quickly you can bring this parallel software architecture into being and deliver. Okay, I want to share with you a few specific examples of deployments, but prior to doing that, we have about 20 or so deployments. I thought what I could do is genericize, if you will, the evaluation of those into a few quick charts and then tell you about one or two specific ones. So, as I mentioned at the beginning, cost of ownership is a big driver in this. Cost of ownership and flexibility are fundamentally the two drivers. So let's talk about cost of ownership. As I look across our deployments and genericize it, what we find fairly consistently is CapEx and OpEx savings of roughly around 70%. So if you can think in terms of the cost of owning your network being a third of what it used to be as you scale, that's a big deal from an operator's standpoint. What we found, and the real issue as you scale is really the trend, and you can see in the chart on the left that the continuing to scale on a traditional model drives a TCO that just exponentially moves away from what you can do in the cloud environment. If we break down sort of where these savings come from, you can look at this online. But a broad, you can see there's quite a few areas where savings come from, but certainly things that are non-technology related, floor space, things like air conditioning, things like that, really end up driving a significant amount of the OpEx part of the savings. CapEx, of course, is obvious from before. And here's, I think, the real kicker. as operators try to really speed up. One of the things that, so this is for a specific customer, but their deployment times typically for new networks have typically run in the 15, 16-month range. And once you've got the network up, putting a service up is another 9 or 10-month experience. In this particular case, the virtual network deployment really happened in about 6 months with service creation times that they're now able to bring up services in weeks. That makes a huge difference to the model. Now, I'll give you an example of one. One of our customers is Elephant Talk. They're a small MVNE, and they've probably been on the faster side of being able to deploy. They were able to go from a standing start on HP hardware, VMware hypervisor, and our application. They were able to go from a standing start to having a network up and running in 3 months. Now, what's really interesting about this is they launched an MVNO for Vodafone, and they now carry a million or so Vodafone subscribers. And they were able to do all this in 3 months for their own network and 3 months to bring the Vodafone launch up for a total of 6. Very different than the experience you might have in trying to do this as a Tier 1 operator. So here you are, a Tier 1 operator who might spend a year doing the same thing, but you've actually got your traffic running on something that can be run intermittently. And this, I think, points to the future in terms of how even Tier 1 operators will be able to move in terms of deploying these types of networks. Here's an example from a Tier 1 mobile network operator. This is a deployment that we did very recently, and it's instead of just the plain vanilla EPC, this is an EPC plus a bunch of the GI LAN services that go on board. It is actually a fairly large network that uses both VMware and KVM in the hypervisor stack. And the operator, what they found with this, it took, by the way, to deploy this took about a year with very extensive testing because it was a first deployment on a large Tier 1 operator. But what they found almost immediately is about a 70-ish% savings in CapEx and OpEx, which is really what drove the start of this migration for them. But the area that they're critically focused on now are all around service provisioning and service chaining, which is driving activation times from months down to weeks. And I think this is an example of how Tier 1 operators are really taking advantage of this, really to drive the two things that they want to do. I would tell you, by the way, that today, when people look at service deployment, they're using the service chaining capability and so forth to really speed up deploying existing services. I think there's a lot of innovation that lies ahead of us in terms of being able to create new services and use those tools. The cost of innovations come way down by being able to put up services quickly, and it allows the operator to experiment more in that regard. This is an example of a deployment that actually uses the Wi-Fi capability in our platform, and this is a large but unconventional operator that's deploying Wi-Fi access on a global scale, and so they started with the trusted wireless access gateway TWAP capability that exists in the platform. I think the real driver for them as they go forward is the ability to roll that into all the subscriber management capability that exists in the platform. And when a subscriber goes off on Wi-Fi, the fact that you can still home that subscriber, manage them, and then deliver services to them gives you a lot more connection, if you will, with the subscriber. And that's what really drives the ability to want to do this and kind of retain the subscriber no matter what type of access they're using. So that's 3 of the deployments that we've been involved in. I guess I would conclude just by telling you that, look, I think market forces are really driving this shift in the world's networks. And I would tell you that today there's really no real penalty, if you will, for going down a virtualized path, simply because what we're finding is in the last 4 or 5 years, the technology has just gotten to a point where it far outperforms the legacy. So you're not really giving up anything to go down this path. And I think that leads us to a tipping point in the marketplace where we're starting to see a lot more activity, a lot more trials, and a lot more faster decision-making in this space. And that's why these deployments are increasing in number. I'll stop there. Thank you.
Thanks, Ahmed. That was great.
Thanks.